All right, hi. This is How to Study for the SAT and ACT Math section, Transversals, More Than Meets the Eye. This is John Linneball Tutoring. I'm John Linneball. You can reach me at john@johnlinneball.com, and my website is www.johnlinneball.com. You can call me at country code 1, that's the United States, area code 415-623-4251. That's my cell phone. Texts are fine too. Or you can call me at 415-986-7355. That's my office landline. What on earth is a transversal anyway? Is it one of these guys? Nope, it's not one of these things. That's a transformer, just like the opening. But they do have more than meets the eye. That's right, transversals are angles in disguise. So here's a transversal. A transversal is a line that cuts across two or more lines that are usually parallel. Here, K is parallel to line L. This is line K. This is line L. You can see they're parallel, which means they never meet. And the red line is a transversal. It cuts across both of them. So, how does that help us? Well, the SAT and ACT people both really like transversals. It's kind of unhealthy how much they like transversals. Anyway, the properties of transversals are such that you can make hard-looking problems that are actually pretty easy, which is why the SAT and ACT people like them. So here we can see we have a transversal that cuts across these two parallel lines, and you can see angle A looks like angle D, which looks like angle E and angle H. And the reason they look like each other on this drawn to scale diagram is they are equal to each other. Same thing goes for B, C, F, and G. So B and F, B, F, A, E, D, and H, and C and G are all corresponding angles that have the same measure when the two lines being crossed are parallel. Why? It's simple. B and C are vertical angles. The transversal crosses both parallel lines at exactly the same angle. So angles B and F have to be the same, and G is a vertical angle with F. The same applies to A, D, E, and H. So what if the lines aren't really parallel? So suppose that the two lines that appear to be parallel really aren't. This can happen if the figure is labeled note, figure not drawn to scale, and there is no notation that indicates the two lines are parallel. So on the SAT, if it says figure not drawn to scale, it's not drawn to scale. That means that they are messing with you. Otherwise, on the SAT, assume that it is drawn to scale. On the ACT, however, there's no guarantee the figure is drawn to scale unless they tell you. So you want to make sure there's some notation that says line K is parallel to line L, or something showing the transversal line is perpendicular, in which case it would go up and down, and there would be a little bracket symbol, a little box that shows it's 90 degrees. If you don't see that, then nothing we discussed is true. So let's say that diagram, if it's drawn to scale, actually looks like this. Here's line here's line K, here's line L. You can see that they cross each other, so they're not parallel. So here you have angle A and angle B, F, E, C, D. So if the drawing's not to scale and nothing tells us lines K and L are parallel, the lines could look like the diagram above. Obviously, we know nothing about the relationships between angles A and C. If these were parallel, these two angles would be congruent, A and C, but they're obviously not here. And also, we do know that A plus B equals 180 because they do add up to a straight line, and a straight line is always 180 degrees. C and D also add up to 180 degrees. They're supplementary angles, which means they add up to 180. And A and E are vertical angles, as are B and F, so those would be equal to each other. So if you get a question like that, and you know that they're not parallel, or they don't tell you they are parallel and it's not drawn to scale, then all you know is supplementary angles, vertical angles. You don't know anything else. Most transversal problems are easy. Don't worry, even if they look hard, most SAT transversal problems are easy. Once you know what angles are equal to each other, you can easily find the measure of at least 7 other angles when you know the measure of 1. For example, if lines L and M are parallel in the figure to the left, we know all the acute angles are 50. See, this is 50, this is 50, this is 50, this is 50. 50, vertical angle, 50, 50. These are called corresponding angles. This, and then this and that. Oh, not this, sorry. Well, this and that. So if all the obtuse angles that are greater than 90 are equal to each other, and all the acute angles that are less than 90 are also equal to each other. So here, since this is 50, we know this has to add up to 180, so this is going to be 130, which means x is also 130. So if they told you to solve for x, you could say, oh, it's 130. How do I know that? Because I know this one's 130, because I know this is 50. And this acute angle is 50, this acute angle is 50, this is 130, this is one because it's vertical to this, and this is 130 because it adds up with 50 to 180. So, okay, we can understand that now, right? Here are a few more transversal problems. So let's solve for x here. So we have angles 1, 2, 3. This presumably is angle 4, 5, 6, 7, and 8. So we know that this obtuse angle is 5x plus 35 degrees, and this is 45 degrees. Okay, so since we know that angle 1 is equal to angle 5, which is equal to angle 8, which is equal to 5x plus 35 degrees, and we know angle 2 is supplementary to angle 1, which has to add up to 180, and it's vertical to angle 3, angle 6 is vertical to a 45 degree angle. So okay, so we know that angle 3 is supplementary to the angle with measure 5x plus 34, or angle 4. So we know that 5x plus 35 degrees, this, plus 45 degrees from here, we know that these two angles have to be the same, is equal to 180. When you do the math and you find out that 5x is equal to 100 degrees, because 45 plus 35 is 80, subtract the 80, you get 5x equals 100 degrees, so x is 20 degrees. In this problem, we have to solve for x and y here. Luckily, we have two equations, so we can solve for two variables. You can't solve a system of equation that has more variables than equations. So we see that 4x plus 6x plus y is equal to 180, and 6x plus y is equal to x plus 5y. Why? Because these are supplementary angles, so 6x plus y plus 4x is 180, and we can see that x plus 5y is corresponding to 6x plus y, so we know that x plus 5y plus 4x is also equal to 180, and we can see that 6x plus y is equal to x plus 5y. So combining like terms in the second equation here, we end up with 5x is equal to 4y, so x is equal to 4y over 5. Why? Because we subtract x from 6x, so we get 5x. We subtract y from 5y, so we get 5x equals 4y. Furthermore, since 6x plus y equals x plus 5y, we know that 4x plus x plus 5y is equal to 180, so 5x plus 5y is equal to 180, and x plus y equals 36. Substituting 4y over 5 for x, 4y over 5 plus y equals 36, so 9y over 5 equals 36, which means y equals 20. Therefore, x is equal to 36 minus 20, which is 16. So here we have a trickier transversal problem, which doesn't look like a transversal problem at first blush, so that's why I said transversals are angles in disguise. In this case, it's even a transversal in disguise. So we have more than meets the eye, transversals, angles in disguise. So okay, we can see that this is 40, this is 30, so we see that angle BCD is 40, and angle BAC is 30, and K is parallel to L, so we know transversal rules apply. So you're probably saying, well, how can we follow instructions and find the measure of angle ABC? That looks like it's really hard, if not impossible. Simple. What we do is this. We're going to draw a third parallel line that's parallel to K and L, and that's going to meet exactly at this vertex here, and we're going to continue these things. If we go back to the previous thing, we're going to continue the red line so it transverses this, and we're going to continue the yellow line so it goes across here. So now we have this, and we can see, oh, okay, since this is 30, when it crosses a parallel line, this is also 30. Since this is 40, this is also 40. Oh, okay. So now what we have is we have A, B, C. Okay. So we know that this angle here is also 40, and we know that this is 30, so ABC has to be 40 plus 30, which is 70. Notice if they asked for this angle here, you could also find out, oh, okay, this is 110 degrees, B, C, and then whatever that is. Or this angle here is 110 degrees. So we just draw a third parallel line, and we extend the red and the yellow lines here, and voila, you have a transversal that helps you solve the equation. So I hope this helped. If you have any comments or questions, leave a comment below or contact me at the phone or email at the beginning of this video. If you like this and want to help me make more videos, like this video and subscribe to my channel. I do in-person and online tutoring for the SAT, ACT, and more. Feel free to contact me. And again, thanks for watching this. Have a good day.